Hey everyone, I'm Karl. Happy to be here today. I'm going to talk to you about TensorFlow and Google Cloud. So what you're going to hear should apply whether you're a new to data science student, or you're starting to use it, or you're somebody that's used machine learning quite a bit and you're just wondering what are some ways that I can better take advantage of machine learning on the cloud. So hopefully a little for everybody. My slides are a little bit light. I'm just going to kind of walk through a few key concepts, and then I want to actually go hands-on. So I want to show you some code. I want to show you notebook environments. That's basically what data scientists use to build models and deploy models. So let's go ahead and get started. Here we go. So the agenda for today, we're going to start with just a quick overview on TensorFlow, the framework, and then we'll cover several different ways that you can use TensorFlow on Google Cloud. We'll mix in a couple demos along the way. So first, an overview. What we're talking about today is related to what Google calls the AI platform. So this is a set of tools for writing models code, for deploying it, for orchestrating a pipeline, all the things that you need to do to build an ML model and put it into a production system. Now, there's a spectrum here. There are technologies like AutoML, pre-trained APIs that don't require bringing your own data, training your own model, and even you can work deeper at the ML infrastructure level. But today, we're going to be talking at that data scientist tooling level about how you can use cloud AI tools. Okay, so let's talk about TensorFlow briefly to kick this off. So TensorFlow is a machine learning framework that's been around since 2015. And you could say that it's much more than a framework. It's really an ecosystem with a core library that allows you to build models, as well as a series of other related libraries that you see below to deploy models, say in the browser, and run some neat web applications with machine learning, as well as IoT and all kinds of other frameworks that you can see in the TensorFlow GitHub project. There's all kinds of neat repositories there. You see a link here to the tutorials. I do think they're really good, really well-written tutorials. We're actually going to go through one today for our demo. Let's talk now about TensorFlow Enterprise. So we heard about TensorFlow, the open source framework. Let's look at Enterprise. So TensorFlow Enterprise is a program for applying TensorFlow to the enterprise, that's the name, states. And let's walk through three different pillars of it. So first is there are performance optimizations when running on Google Cloud. So things like connectors to BigQuery, data warehouse, or Google Cloud Storage, so that you'll improve the performance of your models in the way that TensorFlow is built, takes advantage of the hardware, networking, etc., so you have an optimized experience in Google Cloud. The next part is managed services. So we have a series of services that you can take advantage of to build your models, deploy them, etc., and that's really the heart of what we're going to discuss today. And finally, there's enterprise support. So we've listened to customers who want to anchor on a specific version of TensorFlow. So we have many data scientists who are constantly looking for what's new, the latest version of TensorFlow, and that's great. And we're very excited to support that community. But we also have a set of users who might build a solution and want to stay on that for a while. So when we create TensorFlow Enterprise versions, we basically look at a version that we want to support for about 3 years. And when there's bug fixes, patches, etc., we're making sure that those go into that version of TensorFlow. Okay, so that's TensorFlow Enterprise. So let's start moving on to some of the ways that you can use TensorFlow in the cloud. So we're going to talk about DLVMs, or deep learning virtual machines, and notebooks. So what are some of the pain points with just generally building a model? Is sometimes you've probably seen it when you're installing a bunch of packages, they don't all work together, And maybe you have different team members that are working with different versions of Python packages, different TensorFlow, different scikit-learn, and it's becoming increasingly important that we have reproducible machine learning, that we are all on the same page as far as the framework versions, the code that's used, the you know, GPUs, if you're using those, et cetera, that everything is consistent across multiple environments. So we're going to talk about how deep learning virtual machines can help solve that. So they are a set of images that are pre-configured with everything you need, the library, some accelerator support if needed, and they're very easy to put on a virtual machine. What we call in Google Cloud is Google Compute Engine, or GCE, is the environment to run virtual machines. So let's talk about a related product called AI Platform Notebooks. Might not sound related, but you'll see that it is very tightly integrated. So if you haven't heard of notebooks before, they're basically the IDE for data scientists. They combine an ability to run code cell by cell. So instead of compiling a whole program, you can write little snippets of code and it maintains the state and you can see your experiments run and rerun a cell and that kind of thing. They also support markdown format so that you're able to document what you're doing, because a large part of data science is sharing knowledge and learning and exploring the data. So visualization as well as documentation is a key part of what's included in this notebook environment. And so notebooks run on top of deep learning VMs. They include the Jupyter Lab environment, which will run basically via your browser in that deep learning VM image. Okay, so they're related. The notebook is basically a running on top of that DLVM. And to run a notebook server, it's pretty straightforward. What you see here in the UI is we just simply click a new instance and then we configure it. And it will be pre-configured with TensorFlow. So we'll get started in a second showing that. Let's switch over to a quick demo. Okay, so I want to have something for everybody here today. I want to show a little bit of TensorFlow. We'll get into a machine learning model first. We won't use a lot of cloud technologies, but then we'll build on top of that with using Docker, doing a training job in the cloud, et cetera. But first, let's look at a tutorial. So if you haven't seen it already on the TensorFlow tutorial site, one of my favorite tutorials, if you're getting started with vision, is a tutorial around the fashion MNIST data set. So you may have heard of the MNIST data set. It's kind of the canonical vision data set where you have a set of numbers and you're just trying to figure out 0 through 9, what numbers is it? 28 by 28 images. This is just a little more fun version of that where it's clothing. So what we're going to do is run this notebook in the notebook server. So here I am in the AI platform and you can see a variety of different services I can run. I have a few notebook servers already configured and you can see some details around, how many virtual CPUs, RAM, etc. As I mentioned before, you can click new instance and then you can click one of these, say, with GPUs, without, and then there's advanced customization as well if you want to specify, how much storage, etc. But I have a machine already set up. So let's go ahead and click Open Jupyter Lab. Okay. So here we are. So here we are in the AI Platform Notebooks environment. I'm going to now walk through this notebook to just hopefully leave everybody with a little bit of learning about, data science. I'm going to quickly walk through this tutorial, and then we're going to see how to do this in the cloud as well. So I can just go through each of these notebook cells. Here we go. We're going to classify images of clothing. And I'll just kind of talk about some of the key points. I might skip some not super important details, and I'll try to focus on what matters. So we're going to import some libraries, import the TensorFlow libraries. And then what you see here is we're going to import this data set. And as you see here, it's a bunch of small images of clothing. Next, what we're going to do is import the data. So the TensorFlow framework has some data sets built in. So for testing, for research, you can just pull these out directly from this load data command. So we're going to load the data from the fashion in this data set, and it's just going to populate that automatically for us. And so what you see here, these 4 different categories of data we're downloading. Let's just briefly walk through that. So when we're building a model, we need to train on data, and then we set aside some of the data, say 20% as test data, because we want to see how good our model is. And so what we're doing here is a 4-way split, where we're splitting by train and test data. And then we have the images and then the labels. The labels, or the images being the images. The labels being, is this a shirt? Is this a shoe, etc. And then what we're trying to do is just build the connection between the two and learn, given a new image, which of the 10 types of clothing does it belong into. Okay, so that's that. You see here the 10 different labels, and here we specified them in code. And I'll briefly walk through this. This just kind of talks about the shape of the data set. You know, there's 60,000 images, 28 by 28. Just going to keep moving here. The first thing we're going to do is just take a look at one of the images. And you can see here, this is a boot. Okay, and you can, display images within the notebook. One of the things we start doing is pre-processing it, as you might know, sometimes with color schemes. These are black and white or grayscale images, and they range from 0 to 255. So we want to scale the values from 0 to 1 so that the neural network can learn a little bit quicker. Okay, so a little bit of data pre-processing, not too much. And then what we're going to do is just take the first 25 images and, take a look at the picture and the label. Okay, very cool. Now let's build a model. So the first part, we pulled in some data. Now let's look at what it takes to build a model. So this is the TensorFlow Keras API, the sequential API to be specific. And what that means is that we define here layer after layer of the network in a sequence. There are other APIs if you need to do branching or multiple sets of inputs, things like that. But this is a very common way to do it, which is just simply to say, what's my input layer that starts at the top? And we're saying we are going to take 28 by 28 images and we're going to flatten them so they're one-dimensional. And then what we're going to do is the next layer, think about a funnel. We're going the hidden layer of 128 nodes. And then we're going to end with 10 nodes, 10 outputs, right? Because we're going to learn out of those 10 different possibilities. It's going to produce a probability at the end of this model. Given a picture, 28 by 28, which of the 10 categories does it best belong? So here we're defining the model. We're not actually training it yet. Then what we're going to do is compile the model, where we provide a little more detail on, as we train it, what metrics do we want to use? What function do we want to use to optimize for, the loss function, etc. And we compile the model, and now we're going to actually train it. Okay, so here's where we call the fit method, where we pass in the training images, the labels, and we tell it how many passes through the data or epochs we want to do. So here we're going to do 10. Okay, so it's going to take a little while. What I'm going to do, just to make this go a little faster, let's just change it to 1 epoch. Won't be the most accurate model, but this is a good example of why we do training in the cloud, so that we can kick off a job on a larger system and go through a lot of data, get answers back quickly. But here, we'll just do a 1 pass through the data. Here you see an evaluation method. So we're going to test our model on the test images. Again, the ones we haven't seen yet. And 85%, okay, not bad for 1 epoch. You see that above, when we did it for longer, it got to about 91%. And keep in mind that the model architecture is a very basic one. We're not using a convolutional neural network. We only have 60,000 images. Etc. We could make it more and more accurate. There are plenty of ways to do that, but we're here to learn. Okay, so we trained the model, we evaluated it, and now how to use the model. Let's show how to make predictions. So all we have to do is call the predict function on the model, and we'll pass in some test images. And let's look at what comes out of the model. Okay, so you see these, the scientific notation. It's a little hard to read, but really what this is giving us is a model confidence score for each of the 10 different categories. And we want to pick out of these the maximum one. Which one was the model most confident in? And if you kind of eyeball it, it looks like the last one, the 10th category, or, because it's a zero-based index, number 9 is the right one. So the way to get that is just to get the maximum of the prediction. Oh, well, again, since my model, I took a shortcut, I didn't train as much, I'm not going to have accurate prediction here, but it should, after you do a full training set, it would train 9. Okay, so let's now plot our images, and we'll just kind of take a look. It's a few different images, and look at those probability scores to just explain again how this works. So given an image, the output of the model is a set of probabilities. And you see here for my model that wasn't trained with a lot of time, the 5th category, it looks like it predicts a sandal at 55%. And then I think it was correct with the boot at the second highest, maybe 40%, right? So pretty neat. You can continue to do that through the data set. And again, it's making small mistakes here on footwear, right? It's kind of sandal and sneaker. But, okay, so you can just do this whole process here on the whole set of 25 images. I'll leave this here because this is the fully trained model where you see it's correct for the most part here. Okay. So that was a very quick introduction to the TensorFlow Keras framework and running it inside of AI Platform notebooks. Let's go back to our presentation to look at a few more tools you can use for these tasks. Let's talk about training a model. So if you want to do serverless training with AI Platform, if you don't want to handle infrastructure and you want to take advantage of TensorFlow or other popular data science frameworks, AI Platform Training is a great capability for that. And you can specify if you want to use GPUs or other hardware, and it even has hyperparameter tuning. So when you train, you can specify different inputs, like you saw here with the epochs, or you could have learning rate or batch size or different things. Give it a min and a max, and how many passes through, and it's going to find the optimal parameters as well. So, and it can do distributed training. So once this job runs, then you'll be able to download your model. Typically, you will train it, and then the output of the model will be stored in a Google storage bucket where you can access the model binary files. For serving a model, there's AI Platform Prediction. And so AI Platform Prediction is built on Kubernetes for scalability. And what this does is it provides a serving endpoint. So once you have a model, you deploy it to the cloud, and then you have a REST endpoint that you can access with any ability to access a REST endpoint, or you can use our SDKs, Python, Java, other languages, to access the endpoint from your code. It will scale automatically based on your traffic. You can choose different parameters if you want to turn on auto scaling, and it can even scale back down to 0, but there are some parameters like, do I want to have a minimum number of nodes running? This is very configurable. It also allows you to version your models. So as you deploy them, you can say, hey, I have a new version of it, and give it a new version number, and then you'll be able to see it in the models tab here. Okay. So that's prediction. Let's talk about explanations briefly, which I think is a pretty neat new area of machine learning, which is the goal of which is to have better understanding around your models, especially with neural network models that can be sophisticated. How are they working? Let's take a look at that. So on the AI platform, we offer an explanation service, so you can interpret tabular, text, image models when you use that prediction API to deploy them. We also have a neat open source tool called the What If tool that we won't cover much here, but what's neat about that is you can look at a bunch of different data points and kind of see why did the model predict this for that data point. And you see this the set of values. You can actually change some of the values on the fly and say, okay, if I changed it, from 6 to 7, what happens? Or let's look at the 2 data points that were closest but gave different results and try to figure out what was it that caused that difference between them. So that's the what if tool. We're going to talk about, and it can be used very nicely with the explanations, but let's talk about more about explanations. To use explanations, one way to do it here, there's also an SDK. We have a command line SDK. So for all of the things that I've been showing you, there's G-Cloud. This happens to be a beta feature, but generally, it's G-Cloud, AI platform, and then there's training, predictions, etc. To explain a model, you basically pass in the model, the version of that model, and then the examples that you want to understand why the model predicts the way it does. So let's take a quick look at an example of the information coming back from an explanation. So here we have a data set that's for rental bikes. So, kind of like rental scooters, etc. It's a data set where we're combining the rental bikes with weather, combining those together in BigQuery public data sets. And we're trying to predict the duration of this bike ride. So what you see here is you start with a baseline prediction. So the tool always starts with a baseline, and then, which could be in many cases, the median prediction. And then you have the prediction for your particular item that you're trying to explain. And so in this case, I believe this is in terms of minutes. So the typical prediction is 13 minutes. This prediction is 10.7. Why? Okay, so you see this list of the features and the attribution values. And so what you're seeing here is that given the distance, that was the most significant factor that pushed down the prediction by about 2 minutes. The next item was the starting hour. So maybe due to traffic or other reasons, at that time of the bike ride, again, it made the trip a little bit shorter than typical. Temperature was the next important factor, etc. So this is the kind of information that comes back. It does use JSON, via the command line. You parse it, you get this kind of information. All right, let's talk a little bit about hardware, cloud TPUs. So cloud TPUs enable businesses and researchers to train and run large size ML models at fast speed and scale. They are available on Google Cloud. There's several tutorials for how to connect a TPU to your AI platform notebook. We won't get too deep into that today. And the final technology I want to point out is pipelines. And this is where the next talk is going to go into more depth on. So Cloud AI pipelines allows you to build a reproducible machine learning pipeline. Here you're seeing the UI, where you can take advantage of some components in the TensorFlow extended framework to do things like this. So maybe you read in your data and then you want to validate your data. Well, was the schema matching what I expected it, or do I want to fail my job early? Then, there's some steps around building your model, evaluating your model, maybe having a conditional check. Was this model better than the last one that we built? If so, push it to the production system. So this is where you can use some off-the-shelf components as well as write custom components to create a workflow that works the same every time. It has tracking on your artifacts, etc. Okay, so let's do one more quick demo here of some training in the cloud. So if you recall, we walked through the classification model. Now we're going to look at it in the cloud. So I'm taking the same data set and just showing you how you might package this up in a Docker container and run it on the training service. So first, just some boring stuff, a couple imports. Then I've got a couple constants like what project I'm using, etc. Let's just kind of zip through that. All right, so cloud training. The first step, what I'm going to do is I'm going to create a training directory, and I'm going to create a couple files that is essentially my model building code in that training directory. So the first is something called task.py. And task.py has a few pieces to it. The first part is it has an argument parser. So if you want to pass in custom parameters, you don't have to do this, but if you want to allow configurability, hyperparameter tuning, you might want to provide an input to tweak some things, try new things, so you don't have to build a new Docker container, that your code can accept different inputs. Okay, so here's the model itself. So very similar to what we saw before. I took it to the next level with a convolutional neural network, just because. And then the main method, and this is the code that's actually executed. So if we just walk through this briefly, we're parsing the arguments passed in. We are loading the data, doing a little bit of data pre-processing, compiling, fitting, and then evaluating the model. And then the final step is exporting it to a location. And that's it. So that code, what we're actually doing in this case is we're generating it in a file called task.py. So if I go to this directory, you'll see task.py is there, because we're going to bundle this code and put it inside of a container. So I'm going to create a version of it. So when I train in the cloud, I might want to say my model is within a certain subdirectory, and then I'm going to put a subdirectory within that for the time dates with the time date stamp, so that we don't sort of overwrite the models every time. So just a little bit of versioning here. Then what I typically like to do before building a Docker container is just test it. Let's just try running task.py, again, one epoch, and just make sure there's no syntax errors or anything like that before we put it inside of a container. So it is going to run, in this case, a little bit slower than the last model that we looked at. And let's just look ahead a little bit at what's happening next. So we are going to create a Dockerfile, and a Dockerfile defines your container. It's kind of like the instructions. So let's take a look at what's in that Dockerfile. Pretty straightforward. What we do is the base of the container is one of our TensorFlow 2 Enterprise images, one that contains a GPU, and using version 2.1, we've got a whole suite of different images. And then we're just saying that the work is going to happen in the root directory. We're going to copy the task.py file from our directory here into the container. And then the file that's going to run is task.py when you start the container. That's it. So you're essentially just copying local files into the container and telling it what file do you want to run, our training code. Okay, so I think we're finished here with, and it looks like it did okay. I'm going to now create my Dockerfile. Of course, you saw that I had done this already, but we'll just do it again. Now let's build the container image. So with Docker, what you can do is point it to a Dockerfile, specify the image location. We'll start building that. And then again, another test step I like to do, see that was pretty quick, is test running it locally. So I can run Docker run with a small number of epochs. I'll just skip that step to save a little time. Then we're going to push the image to the container registry. So this is where it's available to you and your team members for training. And it will be in this location. I will just show you that real quick. So these are the different containers that, and latest one is tagged, that we're going to use for training. So let's go back to our notebook. All right, so we've done all the preparation steps. In short, what we did is we just took model code and we packaged it up in a container. Now we're going to submit the AI platform training job. This is that command line that I showed you previously. To submit a training job, there's a few parameters here, what region, what's the name of the image, etc. And then some custom parameters, what you see below the backslash. These are things that if you want to, you can pass into your image. That's sort of your custom arguments. Okay, so it will run, and we're not going to wait for it to set up the job and run, but just wanted to show you've got this ability to submit the training. And then one handy thing you can do here is describe the job. So if within the cell, within the notebook, if you just want to see how's it going, is it preparing, running, completed, you can just kind of rerun this step. Of course, you can also look at it in the UI as well. So we can do that. I'll go ahead and switch to the jobs, and we'll look at one that's already completed. So this is when it's just preparing the job. Let's take a look at one that I've already completed. And click on the job, and you can see some different statistics. But what's kind of neat is, and you can download the model. Let's look at the logs, and this is where you would see the training steps happen. And you can see here, whatever you log, remember this is just running your task.py code, and you might log some things as you go. And here you're seeing TensorFlow saying, each epoch, what the accuracy is, etc. And then you see, okay, great, it trained successfully. So now you've seen how to train on the cloud, how to use the notebook tools, and we gave an introduction to some other tools like prediction that you could use. So, all right, let's just wrap up here with a couple more things. Resources, if you want to find out more, here are a few code labs that you might want to check out. You can, just a wide variety of things, prototyping models in AI platform notebooks, time series forecasting, and then fraud detection. And these all kind of use different flavors and different ways of using TensorFlow. You can find these code labs at codelabs.developers.google.com. And these are just labs, hands-on labs that you can run at your leisure. Click machine learning, and all of these are here, and it just kind of walks you through it, how to do things step by step. It's a great learning resource. So again, that's Google Code Labs. All right.